Okay, yesterday we talked about law of sines, which we use for what's called oblique triangle, so any triangle without a right angle. And we said there are three scenarios in which we could use law of sines. Today we're going to talk about law of cosines, which has its own couple of scenarios to use. Okay, law of cosines is kind of the longer formula, but it's mostly going to be used in the calculator. So this is law of cosines. Starting with the words definition. Okay, the definition of law of cosines in words is it's the square of one side is equal to the sum of squares of the other sides minus twice their product and the cosine of the opposite angle. Okay, so I'm going to break that down piece by piece. Now again, if you're someone that likes the formula, just wait for the formula version. But the square of one side is equal to the sum of squares of the other sides minus twice their product and the cosine of the opposite angle. So there's a lot of words in there. There's a lot of math words in there. So what should we focus on? Okay, let's go through and gather up all the math words in here. Starting with the square of one side. Okay, so it doesn't say what side, but any side. The square of one side is always means equal. The sum of the squares of the other sides minus twice their product and the cosine of the opposite angle. Okay, so we're going to try and get that into a formula just based off that sentence. First, let's label our triangle. Doesn't matter, A, B, and C. Side A, lowercase a, is across from angle A. Side B, lowercase b, is across from angle B. Side C, across from angle C. Alright, so the square of one side, say C squared, that's one side, is equal to the sum of the squares of the other sides, A squared plus B squared. Minus twice their product, minus 2AB, times the cosine of the opposite angle. The opposite angle meaning the angle opposite of C. So C squared equals A squared plus B squared minus 2AB times cosine of C. Notice this formula involves one angle and three sides. Okay. Law of sines didn't have that. Law of sines had an angle on a side and another angle on a side. Okay. Now we just picked A, B, and C arbitrarily. So you could switch, the A, B, and C's, they don't really matter. So there's really three forms of this. You could have B squared equals A squared plus C squared minus 2AC times cosine of B. Or you could have the A squared version, A squared equals B squared plus C squared minus 2AC times cosine of B. Again, it doesn't matter because you just label a triangle however you want, or however it's already labeled. Okay, so those are the same three formulas, just given different, finding different bits of information. The key thing to notice is the bookend. You start with a B, you end with a B. You start with an A, you end with an A. You start with a C, you end with a C. Okay. All right, now three facts we're going to use to help us do this is we use this first one a lot. The sum of the angles of a triangle is always 180 degrees. Okay. Another thing we've talked about, no triangle can have two obtuse angles. Okay, you can't have two angles bigger than 90 degrees if all three of them have to add up to 180 degrees. Okay. So you can only have one obtuse angle. And then we talked about this yesterday too. The longest side is always across from the largest angle. Okay, so the biggest side is always across from the biggest angle. So we're going to use these bits of information to help us out, much like we did with law of sines, much like we did with right triangle trig. All right. So when do we use law of cosines? There are three scenarios where we use law of sines. We're going to have two different scenarios here. The first one being side angle side. Side angle side means you have two sides and you know the angle between them. That was not in law of cosines. The second one, side, side, side. Three sides. You know three sides. You don't know any of the angles. Okay. Also not in law of cosines. But this last one was in law of cosines. Side, side, angle. Okay. Side, side, angle was part of law of cosines with a star next to it. Same thing here. So when you know two sides and the non-included angle. Okay? So two sides and the angle that's not between them. Okay? Like we said yesterday, that gives you an ambiguous case. Okay, and we're going to talk about those cases later, but just know that side-side angle might have some weird things going on. But side angle side and side side guarantee that there will be one unique triangle solution. All right, so let's run through an example. First up is side angle side. Find side C. All right, well, C's right there. Okay. So we're going to find the formula using C squared. Okay. I'm going to rewrite the formula above it so I don't flip over pages. So C squared equals A squared plus B squared minus 2 times A times B times cosine of C. Okay. Again, bookend, C's on both sides. All right, do we know what A squared is? No, but we know A is 12, so 12 squared. Plus side B squared, 20 squared. Minus 2 times A times B. All right, we already knew A, we already know B. Times the cosine of angle C. Okay. So we're going to need to get the angle C. All right, angle C is labeled, it's 40 degrees, so times the cosine of 40. So just fill in what you know. Okay. All right, well, this looks like a really long formula, but the good news is you can just plug that entire thing into the calculator. Now the problem is it's going to give us a number. Okay, you don't have to do any, put the parentheses, just type it in exactly as you see it. And that's going to be our answer for C squared. Okay, so I got 176.2986673. You don't need to go out that far, but I like to be accurate. All right, but we don't care about C squared. We only care about C. So we have to take square root. Now again, this should all just be done in the calculator. So C, side C is equal to 13.3. And that should make sense. Side C shouldn't be 176. That shouldn't make sense if one side's 12, the other side's 20. The third side's not going to be 176. Okay. So 13.3 makes sense in that problem. The second example is side, side, side. It says find the largest angle. How do we know the largest angle? They're not labeled. Well, remember, the largest angle is always across from the longest side. Side B is the longest side, so angle B has to be the largest angle. So we're going to find angle B. Okay? So if we're finding angle B, we have to use the formula that starts with B squared, okay? Which is that one. B squared equals A squared plus C squared minus 2AC times the cosine of B. Notice what we're looking for is at the end. We're trying to find uppercase B. Okay. We know side B was 40. 40 squared equals A squared, 30 squared plus C squared. C is 20, 20 squared. And we're just plugging in the pieces. Plug in A's for A's, C's for C's, and we're trying to find that uppercase B. Oops. Okay. All right, so we got to simplify this. This one's not as easy when you're trying to find the angle. All right, so simplify as much as you can. 40 squared is 1600. 30 squared plus 20 squared. Okay, 30 squared is 900 plus 400. So just go by and simplify everything you can. Okay. Minus, we could multiply those three together. 2 times 30 times 20 is negative 1200. And cosine of B, again, is what we're trying to find. It's what we're trying to isolate. All right, so again, clean up what we can. 900 plus 400 is 1300. Minus 1200 times the cosine of B. Now, what a lot of people want to do in this case, they want to do 1300 minus 1200. You can't do that because of that cosine, because of order of operations. So instead, what we have to do is we have to subtract the 1300 over. Okay. What that does is it isolates the cosine part, or isolates the cosine of B. There's nothing else over there. Okay. So now we need to isolate that cosine part. We're going to divide both sides by negative 1200, whatever's in front. Okay. 300 divided by negative 1200 simplifies to negative 0.25. Okay. And that's going to equal the cosine of B. Okay. Now we just want B by itself. Okay. Remember, when you're trying to get the angle B by itself, you have to take the inverse cosine. So we're going to take inverse cosine of negative 0.25. And we get a B value of 104 degrees. Okay. That's the largest angle. We know that because we can't, it's 104 degrees. We know you can't have more than two obtuse angles. You can have more than two angles that are bigger than 90 degrees. So that has to be the largest angle. Okay, we'll bring it back. Okay, and that's the law of cosines.